A clip started moving through space forms in 2026, showing a faint point of light circled in red, with a caption claiming James Webb had finally photographed Voyager 1, and that the position didn't match what NASA's own tracker was showing. The image looked convincing enough: a blurred dot, a timestamp, an arrow pointing at a smear of pixels sitting slightly off from where the official coordinates said the spacecraft should be. People shared it as proof that something in the official record didn't add up. The comments underneath it filled up fast. Some people asked why NASA hadn't announced the image officially. Others asked why the dot in the photo sat in a slightly different spot than the live tracker on NASA's own website. A few insisted this was the kind of quiet correction agencies make when a public number turns out to be wrong, and nobody wants to draw attention to it. None of those comments stopped to ask the one question that actually mattered. But before asking what Webb supposedly caught, it's worth asking a simpler question first. Could Webb ever actually see Voyager 1 at all? Voyager 1 is not a planet or a moon or comet with a tail of reflected sunlight. It is a machine roughly the size of a small car, built in the 1970s, coasting through the dark more than 25 billion kilometers from Earth. It has no lights of its own except for a radio transmitter running on a fraction of the power of a household light bulb. Whatever sunlight reaches it out, there is already so weak that it barely counts as illumination anymore. To photograph something, a telescope needs light bouncing off it and traveling back to the lens. At Voyager's distance, there's almost nothing left to bounce. That is the problem with the viral clip before any conspiracy even enters the picture. James Webb is an extraordinary instrument built to capture the faint infrared glow of galaxies that formed within a few 100 million years of the Big Bang. But finding a galaxy is different from finding a single object the size of a delivery van sitting 25 billion kilometers away. A galaxy is enormous and made of billions of stars pouring out their own light. Voyager 1 is small, dark, and reflecting almost nothing. Even Webb's mirror, the largest ever launched into space, was never designed to resolve something that faint and that small at that range. It would be like trying to spot a single grain of sand somewhere on the surface of the moon using a backyard telescope. The sand grain does not become visible just because the telescope is powerful. It stays invisible because the physics of light and distance don't allow it to be seen that way. Distance alone would already make this difficult, but distance isn't the only problem working against a photograph. An object only shows up in an image if enough of its light, reflected or emitted, actually reaches the detector. Voyager 1 is not powered by anything that produces visible light. It runs on the heat of decaying plutonium converted quietly into electricity for its instruments and its transmitter, with nothing about that process designed to shine. Whatever faint starlight touches its hull out past the edge of the solar system bounces off in every direction, and by the time a sliver of that scattered light theoretically reached a telescope back on Earth, it would be spread so thin across so much empty space that no realistic exposure time could gather enough of it to form a picture. Long exposures work by collecting more and more light over time, but there is a floor below which no amount of waiting helps, because the light simply isn't arriving in the first place. Voyager 1 sits well beneath that floor for any observatory that exists today, so the photograph never happened, at least not in the way the viral post claimed. NASA has never released an image of Voyager 1 taken by James Webb, and no credible observatory has claimed to capture one either. Which raises the more interesting question: if nobody photographed Voyager 1, then how does NASA know exactly where it is? Precisely enough to state its distance down to the kilometer? And precisely enough to announce, a year in advance, the exact date and the exact minute it will cross a historic distance marker? That answer turns out to be far stranger and far more impressive than any faked photograph. NASA does not find Voyager 1 by looking for it. It finds Voyager 1 by listening to it. The spacecraft still carries a radio transmitter, and that transmitter has been sending a continuous signal back toward Earth for nearly 50 years. On this end, 3 giant antenna complexes make up NASA's deep space network, positioned in California, Spain, and Australia, spaced roughly a third of the way around the globe from each other, so that as Earth rotates, at least one of them always has a clear line toward the spacecraft. When a Voyager signal arrives, engineers don't see a picture. They see a radio wave, and from that wave alone, they can extract almost everything they need. Think of it less like photography and more like sonar, except the ping takes days instead of seconds to return. Engineers measure exactly how long the signal took to reach Earth, and because radio waves travel at the speed of light, that time delay converts directly into a distance. They also measure a subtle shift in the frequency of the signal caused by the spacecraft's motion relative to Earth, the same effect that makes a passing ambulance siren change pitch as it moves toward you and then away. That frequency shift tells them Voyager's speed. Combine the distance, the speed, and decades of tracking. Data and mission navigators can calculate the spacecraft's position with a level of precision that would be impossible for any camera and any resolution from any telescope ever built. This is why NASA can say something that sounds almost absurd in its exactness. As of late 2026, Voyager 1 is expected to cross 1 light day of distance from Earth on November 18th at 2:16 and 7 seconds in the morning, Pacific time. A light day is the distance light itself travels in a full 24 hours, something in the neighborhood of 25.9 billion kilometers. No spacecraft in human history has ever traveled far enough for that number to mean anything. Voyager 1 is about to be the first. None of that precision comes from a single lucky measurement. It comes from decades of the same radio tracking, repeated so many times, that Voyager's path has become one of the most thoroughly understood trajectories in the history of spaceflight. Every session with the Deep Space Network adds another data point to a model that already accounts. So, for the pull of every planet, Voyager passed on its way out, the tiny push of sunlight on its structure, and even the almost imperceptible nudge from heat radiating unevenly off its own instruments. Engineers don't need a fresh photograph to know where the spacecraft is going next, because they've effectively been rehearsing this exact prediction for nearly 50 years, refining it a little more with every single signal that arrives. It's worth pausing on what that milestone actually costs the mission. Right now, a radio command sent from Earth needs more than 23 hours just to arrive at the spacecraft. Once Voyager crosses the 1 light day mark, that climbs to a full 20. 4 hours out and another 24 hours back, meaning engineers wait 2 entire days to learn whether a single instruction was even received. There is no live conversation with Voyager 1 anymore, and there hasn't been for a long time. There's only a very slow, very expensive exchange of letters, carried at the fastest speed the universe allows. That delay is also where the real version of "it's not where NASA said" quietly lives, and it has nothing to do with a secret Webb photograph. Because Voyager 1 is still moving outward at around 17 kilometers every second, the spacecraft that sent today's signal is not the spacecraft sitting at the coordinates on the page right now. By the time that radio wave crosses 25 billion kilometers and lands at a dish in Australia, roughly a day has passed, and in that day, Voyager has already traveled more than 1 million kilometers further into the dark. Mission trackers, therefore, have to make a choice. Do they report where the spacecraft was when it sent the signal, which is the position the actual data describes, or do they report where the spacecraft is estimated to be right now, using its known speed to project forward? NASA's official tracking page and independent trackers, built from the same RAW, orbital data, don't always agree on which of those 2 numbers to display, and the gap between them can run to 1 million kilometers or more. Anyone comparing 2 different sources at the same moment could genuinely see 2 different positions for the same spacecraft, both technically correct, both describing the same object, just anchored to 2 different points in time. That is a real discrepancy. It is just not the one the viral post described. Nobody manipulated an image and nobody hid a photograph. The mismatch is built into the nature of talking to something so far away that its own past and its own present are no longer the same place. Voyager 1's story only gets stranger the closer you look at what keeps it running. Its power source is not solar, because sunlight this far from home is too weak to matter. Instead, 3 generators convert the heat from decaying plutonium into electricity, a process that has been quietly losing strength every year since launch. Engineers have spent the last decade shutting down onboard instruments one at a time, not because they failed, but because there simply isn't enough power left to run everything at once. The cameras were switched off back in 1990, right after taking one final image of Earth as a single blue pixel lost in a scattering of sunlight, later named the pale blue dot. That image is the closest thing Voyager 1 has to a self-portrait, and it was taken looking backward, not forward, and not any time recently. By 2026, only a couple of science instruments were still drawing power, listening for plasma, waves and tracing the faint magnetic fields of interstellar space. The region Voyager 1 entered back in 2012, when it crossed the heliopause, the boundary where the outward pressure of the sun's solar wind finally gives way to the pressure of the wider galaxy. Everything else has gone quiet to keep the spacecraft warm enough and awake enough to keep talking at all. Earlier in 2026, engineers made the deliberate choice to switch off one of the last remaining science instruments, a charged particle detector that had run almost continuously since launch, simply because there wasn't enough power left to justify keeping it on. Every one of these decisions is made the same way, weighed months in advance, sent as a command that takes nearly a full day to arrive, and confirmed only once. A reply eventually makes the same long trip home. Even staying in contact has become its own kind of drama. In 2023, a corrupted piece of onboard memory scrambled the telemetry Voyager 1 was sending home, turning what should have been readable engineering data into what engineers described as gibberish, a signal that was clearly there but made no sense. It took months of remote diagnosis, using a spacecraft nearly 50 years old and running on computing power a modern calculator would outpace before engineers found the fault and coaxed it back into working order. Then, in 2025, the single antenna capable of sending high-powered commands to either Voyager craft went offline for an extended series of upgrades, meaning for long stretches the team could listen but barely speak back. It came back online in time to keep the mission alive, heading into 2026, but the margin for error at this distance has never been thin. So where does that leave the viral claim? The honest answer is that it collapses the moment it's tested against how observation and distance actually work. James Webb was never going to be the instrument that photographed Voyager 1, not because of some restriction or cover-up, but because a picture out of light that was never there to capture in the first place. What actually exists, instead, is arguably more remarkable than a photograph would have been. A machine built before most of its own mission controllers were born, still transmitting a whisper of radio energy across a gap so vast that the whisper itself needs a full day just to cross it, still being tracked with pinpoint accuracy by engineers who have never once needed to see it to know exactly where it is. There's a strange kind of intimacy in that. No camera has looked at Voyager 1 in 36 years, and yet NASA can tell you, right now, how many kilometers separate it from Earth, how fast it's moving, and what season of interstellar space it's currently passing through. The precision doesn't come from watching, it comes from listening carefully, enough for long enough that a signal thinner than a whisper can still tell the whole story. And there's something almost fitting about the fact that the discrepancy people noticed was real, just aimed at the wrong explanation. Voyager 1 genuinely isn't exactly where NASA said, depending on which number you're reading and when it was calculated, because the spacecraft is always a little further along than the data describes it to be. The truth wasn't a hidden photograph. It was the simple, dizzying fact that by the time any message from Voyager 1 reaches us, the sender has already moved on, somewhere out past 170 times the distance from Earth to the Sun in a region of space. No human being has ever visited. A spacecraft the size of a small car keeps counting down toward the day. It becomes the first human-made object, a full light day from home. Nobody will photograph that moment. Nobody needs to. The numbers will simply tick over, exact to the second, and Voyager 1 will keep moving outward, already. Gone from the position it just reported, on its way to somewhere the data hasn't caught up to yet. If you had to bet, which feels more incredible, a blurry photograph nobody can actually verify, or the fact that engineers can pinpoint a machine's location to the kilometer using nothing but a radio whisper sent across. 25 billion kilometers of empty space? Drop your answer in the comments, and if this is the first time you've heard the real story behind that viral clip, you know what to do next.